Okay, so here is our our Algebra 2 video for today. Okay, and this is about logarithms and exponents. And before, last time we were together, okay, we defined the idea of a logarithmic function. We said that a logarithmic function was one where you would start with an exponential function, or an exponential equation like y is equal to 2 to the x. And what we would do is we would switch the x and the y, right? And in fact, we said that the log and the exponential functions were inverses of each other, okay? We said, okay, so if this is the exponential function, y and then x and then 2 to the x, that's what y is equal to, then that was, if we had these values here, right, then to form the equivalent logarithmic function, which we wrote like this, all right, we flipped the x and the y. What was the x became the y, what was the y became the x, and we had this function over here. And then we plotted, we graphed some of those, right, to see what they would look like. And so this is our logarithmic function, okay? So in other words, if we've got y is equal 2 to the x, if that's the exponential function, then the equivalent logarithmic function is going to look like this. A red arrow there, and I'll use black pen here. It's going to be log base 2 of x is equal to y, right? So keep in mind that I'm going to show here, the base numbers are the same, okay? The log base and the exponential function are exactly the same, okay? And you see here that we've switched the x and the y. So this is the input value for the logarithm, and this is the output value for the logarithm. So these values here, those are the input values. That's what's going to go in for x, and these here are the output values. Those are what are going to go in for y. Okay? So in other words, so we're going to be converting from one value, from one kind of function to the other. So for instance, and we'll start with numerical expressions first. So for instance, let's say we know that that 2 to the third power is equal to 8. We know that's true, right? So the equivalent log expression is going to be log base 8, log base 2 of 8 is equal to 3. This base, that base are the same, and see the x and the y values have simply switched position. That's how it works. Okay? So this is kind of the first thing we want to be able to do here, is to convert from an exponential expression to its equivalent log expression, or the other way around. Okay, but let's try some more log expressions, and we should also do some of these on our calculators as well, so that you believe me when I say, oh yes, this is going to really work, okay? So anyway, we'll try some calculator expressions in a minute here. So this is what we're going to do. We're going to convert from an exponential to a log expression, okay? So let's say we know that 3 to the second power is equal to 9, right? Well, that means that log base 3 of 9 is equal to 2. And you can see within each log expression, you can see the exponential expression is still there. See right here. 2 to the third power, that's 8. 3 to the second power, that's 9. The base number stays the same. The x and the y are switching positions. Now you're going, well, okay, but so what? Okay, it turns out that these logarithmic expressions have useful properties that we're going to use that can be used for different kinds of problem-solving situations. And another thing is we can use them to solve exponential equations. Okay, so let's try another one here. I'm going to do 10 to the 4th power, as it happens, is equal to 10,000. 10, that's 10 times 10 times 10 times 10, right? Well, the equivalent log expression would be log base 10 of 1,000 is equal to 4. You can see here again, there's that exponential expression, 10 to the 4th power is equal to 1,000. Okay? Okay, so I'm gonna put another one up here, and I want you, as soon as I write this down, to pause the video and try this on your own. Just hit pause on the video and try it on your own. Of course, you don't have to. You can keep going and see the answer, but it's better. I'd like you to try this on your own if you feel like you can. How about this? 4 squared is equal to 16. What's the equivalent log expression? Log base 4 of 16 is equal to 2. See? Don't need that equal sign in the middle there. Log base 4 of 16 is equal to 2. See that? 4 to the 2nd power is equal to 2. Okay? So that's how that works. They don't have to be all numbers. So, for example, if we've got an exponential equation like this, 2 to the x is equal to 9, we can write that as a log expression, log base 2 again, of 9 is equal to x. So that is a logarithmic equation. See again, 2 base 2 to the x power equals 9. Okay? Okay, so that's that. Okay, so at this point I'm going to put several down here, and I'd like you to again pause the video and try these on your own. So we've had, this is actually, I forgot to number them earlier, but this is example 4 and this is example 5. So here are some more. Try these, right? Pause video. Okay, so 4 cubed is equal to 64. Okay, write that as a logarithm. How about oopsie, not that one. How about 3 to the x is equal to 7? Write that as a logarithm. How about 4 to the 1st power is equal to 4? Write that as a logarithm. Ooh, and now how about this one? Let's see if you can get this one, keeping in mind the log values we had before. 2 to the 1/2. Oopsie. Okay, not 2 to the 1/2, sorry. 2 to the -2 is equal to 1/4. Write that as its equivalent log value. Okay? All right, so go ahead, try those out, and when you're done, come back. Okay, welcome back. So what do we got? We're going to change these into logarithms, okay? So this is going to be log base 4 of 64 is equal to 3. This one is log base 3 of 7 is equal to x. This one is log base 4 of 4 is equal to 1. This one is log base 2 of 1/4 is equal to negative 2. Okay? And again, as you see, it's just turned around. Alrighty? Okay, so that's the first part where we're changing exponents to logarithms. Now, of course, we want to be able to do it the other way around. Okay? Put that aside here. Okay, so this is changing, I'll write it up here, changing logarithms to their equivalent exponential expressions, right? So let's start with a logarithm. How about log base 5 of 25 is equal to 2. Okay, that's 1. How about log base 3 of 27 is equal to 3? How about log base 3 of 1/9 is equal to negative 2? And how about log base 6 of 36? That's equal to 2. Okay? And how about this one here, log base 7 of 1/49? That's equal to negative 2. And how about this one, log base 3 of x is equal to 12. Okay? So that's one with an x in it, which is one that we'll be doing at some further later time. Okay? So if you want, you can go ahead and you can, if you think you've got this and you think you know how they'll convert back based on what we were just doing, why don't you just go ahead and pause the video right now and then come back, restart the video again, and see what the answer is, okay? Ready, go. Pause the video. Okay, so keep in mind that the log bases, which I'm circling here, those are the exponential bases. And then inside the log expression is the equivalent exponential expression. So for the first one, 5 to the second power would be 25. So our equivalent exponential expression is 5 squared is equal to 25. It's a little hard to see. I'll use black here. Okay. Here is the equivalent exponential expression. Okay. Inside the log expression, 3 to the third power is 27. Okay. Here is the exponential expression. 3 to the negative 2 is 1/9. Here is the exponential expression. 6 squared is 36. Here is the exponential expression. 7 to the negative 2 is 1/49. All right, because, and why is that? Because that's 1/7 squared, right? Okay, so, but that's how we'll write the answer right there. Okay, then this last one here, okay, exponential expression, logarithmic, or rather the exponential expression is inside the logarithmic expression. We see 3 to the 12 is equal to x. Okay, does that make sense? Okay, so you've been listening to about 15 minutes, it looks like here. So So what I'm going to do is I'm going to save this. I'm going to pause the video here, and I'm going to or rather stop this video here. This will be like part 1, and then there'll be a part 2, which you can get to after you've done part 1. Now what you should do now is find the practice problems that I have uploaded, print those out, and then just do the first few, the part that says changing logarithms to exponential expressions and changing exponential expressions back to logarithms, and either way, it'll be about the first 10 of the problems. You should do those, and then the next section is what the next video will be about. Thank you.